So how are we going to make this from two of these? That's the question. How do we get this yellow substance that came from two clear substances? And so in the world of chemistry, we have things known as double replacement reactions. And so in each of these beakers, I have a material. In the beaker on the left, I have potassium iodide, and in the beaker on the right, I have lead nitrate. So we have Ki, and we have PbNO3 for our lead nitrate. And so what happens is when I dissolve these both in water, they both have the ability to move around because those bonds are broken, and now we have positive and negative ions. So in this beaker I have positive K and negative I. And in this beaker I have positive Pb and negative NO3. And so if you notice on the label, this was actually lead 2 nitrate. So this would be positive Pb plus 2. And so what happens is the positive from one side, from this one, can actually react with the negative from this one. But they have to be able to, of course, contact. And so as soon as I start to add, I'm going to take this pipette out of the way. We're going to remove that from the situation. And as soon as we take this in here, I'm going to hold this kind of sideways. As soon as I start to drip this in here, boom, we now have the magic. We have the creation of lead iodide, because I've taken the lead from one and I've reacted it with the iodine from another. And so you can just see it's kind of murky and kind of like a solid in there. Not kind of like, it actually is. It's known as a precipitate. So it's a solid material that forms when two liquids have ions in solution. And so something like this you have to be really careful with, because if I were to take this and look at the solubility charts, for example, in the chemistry world for New York State Regents, table G, we have solubilities. We see that lead nitrate is soluble in water, this one here, and we see that potassium iodide is soluble in water, and we say, hey, those are good. Now, you would never want to really throw lead components down your sink, because eventually they're going to get into the water supply. Maybe they're going into a lake. The fish is going to eat it and breathe it in, and then it gets in the fish, and then you eat the fish, and so you end up with lead poisoning. So you have to be very careful. I'm going to let this stuff settle out overnight, and I will basically go through the process of filtration. So check the video out for the next one for filtration, and we will dispose of this properly. Because if you just think these two clear liquids are going to be fine in the beginning, but then you dump them in the drain or down the drain, later on they might form this product instead, and so now we have a different material that might settle to the bottom of the lake. It gets in the soil, and maybe if there's a bottom feeder fish and it's digging up underneath there, they're going to take that in. It's going to become maybe part of their tissue, and then you could consume that. So again, things to be aware of when you are playing around with chemicals. And again, this has been a double replacement reaction that shows how I can have two soluble materials, but when you mix two soluble materials together, the things that were in both of those might not be soluble together. So in this case, it was the lead from the lead nitrate over in this container, and it was the iodine from the potassium iodide in this container, and those two went together. So it was a positive from this one and a negative from this one. They came together. Now, over time, I did another little small example on a little watch glass. You can see how the materials have started to settle because the watch glass is curved down. So we have what looks like a powder in the bottom. We still have some that's all the way around, and eventually that would kind of settle down to the middle, especially if I spun it around a little bit. But we still have some clear liquid, and that clear liquid is still going to be the rest of the residue of not only the potassium and the nitrate, but also some of the original water that is there as well. So again, double replacement reactions typically end up in a precipitate, but they don't always have to end up in a precipitate. Sometimes you can have soluble materials end up with soluble materials, and all you got to do is look at your reference table to determine that. Again, in New York State, that would be reference table F to figure out the solubility guidelines and see whether or not materials would be safe to dispose of down the drain. So this has been Mr. Gardner with chemistry, and hopefully you've picked up something that will help you in your future classes. Take care.